All right, so we've been talking about electron configuration, and now we're going to take that next step. If you haven't heard me talk about it before, I talk about how sometimes scientists and engineers get lazy. They don't want to repeat things a million times. So we can use that noble gas configuration, or those maximum points, to help us in a substitution. So in period 1, or energy level 1, the maximum we can have is 1s2, and our noble gas helium has that. In period 2, we have 2s2, 2p6 to get to neon. And so neon's electronic configuration is equal to 1s2, 2s2, 2p6. And I'm going to put some brackets around that because I'm going to be substituting. Okay? So normally we would have written neon as 1s2, 2s2, 2p6, and we've just written it all there in a line. But when I do it as a substitution, I put those brackets around it. And what does a substitution mean? Let's try one. So sodium is 1s2, 2s2, 2p6, 3s1. So we went down to that third energy level because sodium is right here. So if I added up all the electrons, 1s1, 1s2, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6, 3s1. That's how I got that electronic configuration. But this whole first part is the same as neon. This is just neon. So why do I need to keep writing that whole beginning part out a million times? I don't. I could just say sodium is neon and 3s1. Let me rewrite that so we can see it a little bit clearer. Sodium is abbreviated with neon, and then 3s1 is the only extra one that's there. So neon took us this whole first part, and then 3s1 is the only new one. We also know that that means that there's only one valence electron. Okay, let's do another example. So if we wanted to do lithium, or we already did a group one, let's do beryllium. So beryllium, 1s2, 2s2, 1s1, 1s2, 2s1, 2s2. So I could substitute in, but I have to go back and say, what is the last noble gas? And the last noble gas used was helium, and helium is a 1s2. So now I can take this 1s2 and substitute in here for beryllium. Beryllium, put the brackets to say I'm substituting in helium's electron configuration, and I'm left with 2s2. Most of the time we wouldn't bother substituting for this because if you saw, it's just as many pen strokes as the other. But I just wanted to show you it was possible, and it also helps you see that beryllium has 2 valence electrons. So let's go a little bit further here. Let's do this guy. That's chlorine. Okay. Chlorine is 1s2, 2s2, 2p6, 3s2, 3p1, 2, 3, 4, 5. So now I'm going to go back to the last noble gas, and I get this guy. Who's that? That's neon. Okay. Neon is 1s2, 2s2, 2p6 for 10 total electrons. So the first 10 electrons here, 1s2, 2s2, 2p6, can just be substituted in as neon. How would I write that? Write chlorine the same. Then I'd write neon in brackets. And then I just write what's left. 3s2, 3p5. I can do this with every single one of them. So if I wanted to do potassium down here at group 4, then I would look back. What's the last noble gas? The last noble gas is argon right here. So potassium's electron configuration, we're substituting in argon, and then we're just writing what's on that next row, which is 4s1, which tells me that there's one valence electron in potassium.